This law of radical is about the quotient law or the quotient rule. This tells us that if we have an expression like this, that is actually an nth root of a certain radical expression that is expressed as a form of a rational expression or fraction, we can just simply break down our radical expression here, give it to our numerator and denominator as long as it has the same index here. This is made possible so that if A or B or both can be simplified with the index here, so we can act it in this manner. But take note that B should be equal to 0 so that this will not be undefined. To show, again, let's not forget that A and B are what we call as our radicand. And our N is our index. So let us show from here, we will reach here. So let's start with the idea that we have here nth root of a fractional expression A over B. Okay, take note again, B is not equal to 0, so that this will not be undefined. Now, if we have a radical expression, or specifically this here, nth root, this could be transformed into an expression with fractional exponent. Okay? Take note that this could be written as with power of 1. And we could transform it in this manner, copying a radicand now, A over B, now raised, without radical expression now raised to a fractional exponent, where this exponent here becomes the numerator, and the index becomes your denominator. So these two are just equal. That would mean that any radical expression would give us a fractional, an expression with fractional exponent, or vice versa. Okay? Now, from here, we are going to use here the power law, specifically on the power of a quotient. We can actually act this one here. Take note, this has a power 1. This also has a power 1. Power law of exponents tells us that we can just simply multiply exponents. Then we have here A to the power of 1 over n, as it's 1 times 1 over n is 1 over n. This is also true with our denominator, 1 over n. Okay, that's also what happens to our denominator, because we have here 1 times 1 over n. Now, in this mind here, we can now return to an expression with radical expression, being again the n here, or the denominator, becomes the index. That would mean nth root of A to the power of 1 over the nth root for our denominator of B to the power of 1, which will give us an expression equal to nth root of A over nth root of B. This shows that the nth root of a fraction expressed as A over B is just equal to the nth root of A over the nth root of B, where again B is not 0, so that this will not be undefined. This is the proof for the quotient law of radicals. This is again properties, laws, and theorems. Please subscribe now.